All right, Jalen, did your mic work?
Yeah.
All right, go for it, Jalen.
Verse the first education class is sacred. We never behave with us, create ourselves as well. The Still Academy Southwest student always acts integrity and take part in Still Academy Southwest. Respect the opinions of others, respect the culture of the classroom, generally participate, be a house teacher, say that in our teacher, we got here some kind of stuff for sick endeavors.
Okay, thank you. And let's move on. Got one more for you, Jalen. Go ahead.
Please keep camera on. To call public school policy for the third duration class, you must be a tenor participant or you'll be removed from class due to lack of activity. You mark less than 24 days in when you will automatically fail the course and be required to retake the material in order to the grade.
Okay. Let's see
I'm
here.
ready.
So, Rush, are you?
GGI Townhouse, Monday through Friday, 11:15 a.m. Please encourage your peers. Oh, we only got Jalen in here. I think I'm talking to a whole audience. Please encourage your peers to participate and attend. Um, Mr. Tyler is one of the many that gives out credit and extra credit towards your assignments for participation and attendance. So please join and attend GGI Townhouse and participate. Raspberry Pi kits, please, if you do not have one, let us know so we can get you one. If you do have one and is having issues, any kind of technical difficulties, please let me and Mr. Tyler know so Mr. Tyler can troubleshoot it. If he cannot successfully troubleshoot it, we can swap it out for you for a new one. So please let us know your situation so we can fix it.
Okay, I'll take care of this one. GGI, not GGI, I'm sorry. Every Wednesday and Thursday, Learn the Code is actually tonight. Uh, you can get extra credit in my class, especially as a double credit assignments. So if you really want to put a dent in some of your scores, try to attend two topics at hand: the pandemic's effect on the coding job market, why learn to code, the surprising broad benefits of coding. Now, these are two links, right? So you can click on these links and actually get credit for them if you actually read through it and give a one-page report, essay form, and turn it in to me as a message in SB. I'll review it, and that could recover a due now and even boost up part of a quiz score. So just something to think about. The link to go is at 4 p.m. This little 4 p.m. link here. That's how you get into the actual session with Miss Lane and myself. All right, Jalen, so you're going to take the rest. Go ahead.
Anytime you're able to complete the evaluation as the Hello Oscar Simpson one class, start as offering for the videos of each class if it's on really ready to about 4 p.m. daily. We'll be able to do live Pluto and online calls with Kinetic and potential energy module to evaluate problems involve kinetic energy and potential energy. That's the intended gravity order they demand.
Okay, I was waiting for him to unmute himself. Cool. All right. So now let me do this so I can be sure to read what he's saying. Yeah, there we go. There's Michaela. I got to do attendance again. One moment. So everybody, make sure you log into SB because that's the next step. Give me 1 second. I got to log attendance. Okay, Michaela, that's kind of tricky. You said you had I think that was you. You told me you had an appointment or
Fourth period.
interview.
I said the fourth.
Oh, fourth period. I thought you said second period. Okay. Cool. All right. And did you get my message about that assessment? I unlocked it again, or Rush unlocked it for you.
Yeah.
Okay. All right. So we're going to go through Plato again. This time it's for physics. So let's come out of this. And bear in mind that this exit slip is information on the screen. You have access to the information. Let me switch classes. So today's class is physics, right? Second period. And if you're in SB, you'll see all this. At the top of the list is, of course, your GGI information that was mentioned by Mr. Rush a moment ago. Now, here is your actual assignment. You can see this in the classroom view, or you could take advantage of it from the My Work Assessments view. So either way, and we'll take this in two parts. Kylie, you just got here, so I'm going to have you read this for us. It's worth 45 points. So let me first grab all the info. Copy this. That component. And the last component is this. All right, Kyla, can you read from hello all the way down? You don't have to read the links necessarily, though.
Hello again, my physics for algebra students. The link for my bit emoji classroom is we'll begin utilizing the Plato elementum curriculum online to complete today's assigned module, kinetic and potential energy. Please follow the instructions below. Your coursework is illustrated via this link. You need to be sure that you have access to a laptop or a personal computer to be successful with all projects. You'll be required to take your time and pay attention to the instructions of each module in order to be successful with obtaining at least 80% or higher of the overall completion. The coursework is illustrated via this link. You'll need to be sure that you have access to a laptop or personal computer to be successful with all projects. You'll be required to take your time and pay attention to the instructions of each module in order to be successful with obtaining at least 80% or higher of the overall completion. If your score is less than 80%, you'll be required to retry the lab until the appropriate score is achieved. Starting an exit template is take out the
Good job, Michaela.
All right, Michaela, great job. All right, so let's jump into today's assignment real quick. She got 40 points for that. So the first part is at the very bottom, your exit slip. Everybody should have access to the exit slip information. That's the easiest part of today you have to do. You're going to take the information from the objective, the classroom term today, is definition and word of the day, and you're going to put that into your exit slip so you can get the 30 points towards your class score. Now, the other component is, of course, Plato. So let's log in together. The link for Plato is right in the middle of what she read. And you'll get this screen right here. Now, remember, everyone's should have an account. Everyone should know what their password information is. You start off with CERL for your account. And then, of course, it's going to be your first and last name. And then last part is, of course, the password I gave you. So put in your password. And the modules we're in, make sure you go to, I'll show you what on the screen, which one it is. You're going to go down to, where we at? Physics. This would be the last one in my view. So it's going to be physics with Algebra Q4. And let's take a look so far. It looks like people are starting to take pace. All right. We'll come back to that on Wednesday for data talks. All right, so the section we was in yesterday was, I think, in Unit 4, right? Come all the way down. And we were working on energy. So energy and momentum is the name of the game for this section. We should have had the work mastery test completed. We're now moving into kinetic and potential energy. So let's go a bit through the tutorial a little bit to understand it. You have future goals, math and science. You've seen this stuff before. It's not hard. That's why I did it this way. But now we're about to delve into the technical aspects of it so you can have a well-rounded physics class, okay? So this is just the final reinforcement topics. So let me change screens. Google wants me to do that. Activities. So let me stop presenting. And then I'm gonna do this. I have to start it off here, right? Okay, so should see my screen. I'm going to mute myself. We're going to go through a little bit of it together.
Kinetic and potential energy. In this lesson, you will solve problems involving kinetic energy and potential energy. Introduction. When players set a soccer ball in motion with their feet, legs, or heads, they're demonstrating force in action. When we apply force to an object, we usually want it to move, stop, or change direction. In the world of physics, we're doing work on the object. In physics, the ability to do work is called energy. Think about the energy in a simple rubber band. In its natural state, it has none. But if you stretch it over your finger, put a pebble in it, and let it go, it flings the pebble away. There's a bit of stored energy in that stretched rubber band. You'll study what kind of energy that is in this lesson. Here's another example. A stone resting on a sheet of glass doesn't have energy, but there is some energy in the stone if you raise it above the glass. There's also energy in the stone when you drop it. Here's one more example. A parked car can do nothing, but a car in motion can. The parked car has one type of energy, and the moving car has another type. In this lesson, you'll look at each of these examples in detail to learn more about the types of energy. Potential energy. A stone raised above a sheet of glass has some energy because, if released, it will fall on the glass and break it. Any falling object accelerates toward the ground due to gravitational force. This force, which acts on an object, depends on the mass of the object. A heavy object will be pulled toward the ground with greater force than a lighter one. The acceleration of an object while falling due to gravity is denoted by g. The force of gravity does the work on the object by pulling it toward the ground. So force does work, and energy is the capacity to do work. Because of its position over the glass, the raised stone has the potential to break the glass. Energy that an object has due to its position is potential energy. Let's look at potential energy in more detail. Potential energy is energy stored in a body that can be used for doing work later. For example, a wrecking ball demolishes buildings. Before striking the wall, someone pulls it back and releases it to hit the wall. The farther you pull it back, the more impact it has on the wall. The position of the wrecking ball determines how much potential energy the ball has. A bow and arrow is similar. The more you pull the bowstring, the farther the arrow is likely to go. The position of the bowstring has an impact on the distance covered by the arrow. In other words, the position of the bowstring determines how much potential energy the bowstring has. The potential energy of the wrecking ball and the bowstring isn't due to gravity alone because these objects aren't free falling. Any type of force can create potential energy. Potential energy is classified based on the type of force involved. An arrow in a bow, a raised stone, or a charged particle in an electric field all have potential energy, but each one has a different energy relationship. Common types of potential energy include mechanical and gravitational. Less well-known are these field forces: electromagnetic, strong nuclear force, and weak nuclear forces. Let's look at types of potential energy. Mechanical potential energy. The objective objective of mechanical potential energy is to restore objects to their original or natural positions. A stretched rubber band has the capacity to fling a pebble. A bow has the capacity to fling an arrow. Other examples of mechanical potential energy include a taut guitar string, a yo-yo, and a compressed spring. Gravitational potential energy. As its name implies, gravitational potential energy is energy generated by gravity. It's the type stored in a raised stone. The magnitude of this energy depends on two factors: the mass of the object and its height from the ground. In other words, the higher a stone is raised above a sheet of glass, the more impact it will have on the glass when it's dropped. Work is done on the glass when the stone falls on it. Potential energy from other field forces. Any of the three other field forces, electromagnetic, strong nuclear, or weak nuclear forces, can be a source of potential energy. Here's an example of electromagnetic potential energy. A magnet attracts iron because the magnet has a magnetic field. An iron in the magnetic field is attracted to it. Because it is drawn to the magnet, iron in a magnetic field has electromagnetic potential energy.
Okay, so I want to slow down here and do a simulation real quick that could probably help us understand better what's going on. And then we're going to do a few questions together. So give me a moment, let it load, stop this. And because when I share, I notice the resources of my computer go down. Who would like to be using that? But inside of your Bitmoji classroom, there are some activities. We're going to do one of them together. Just try to share again. Okay, so if you take a look here, we got these magnets right here, right? So, Jalen, are you able to get to the Bitmoji classroom? Are you asleep over there, my man? Wake up. You see these magnets, everybody? Kyla? Okay. All right, so click on the magnets, and it has a run. So everybody should have clicked on this link so you can actually participate. All right, so this is a quick example of how this works. Now I'm going to leave this here for 5 minutes. I want you to figure out how to get the light bulb to work. And then I want you to explain to me in your own words why it works. All right, so 5 minutes, you should be on this simulation. And then I'll be asking each of you, how does it work? Okay, you say what, Jalen?
Which slide is that on?
You said what, Michaela?
Which slide is it on?
It's in the physics slide.
But okay, what number?
Let's look more closely at the effect of mass and speed.
You in the classroom?
Yeah, what number slide? What number?
So okay, are you okay? So you're in this, right? Right?
That's what I gotta go to?
Yeah. We're doing a quick activity. So you got to hit present to make the slide deck work. And then once you get there in the class, click on the magnets. The goal is to tell me how to make that system work. You found it?
It's loading.
Okay. So remember, Jalen and Kyla, the goal is, oh, hey, Tyshawn, did you see what I did or no? Just saw your name pop up.
You said what?
Do you know what to do? Do you know what we're doing?
Well, we on the next assignment or something.
Next time, some. Okay. Let me just talk about the class sometimes so you don't get lost in the sauce. You go to your Bitmoji classroom. Huh? Look at magnets. You on generator? You on generator? Okay. Look at the tabs. You see what is called generator? Okay, so look, I just found out from Jalen, there's two magnets in there. The second magnet is for generator. The first magnet is for magnet and compass. So maybe I should explain that and give you a little more time to work on it. So about 5 more minutes. And then again, the goal is for you guys to tell me how to make the light bulb turn on and why is it turning on. Keep in mind, you can't say it's plugged up, right? So you got to figure out why it's on or how to turn it on. Okay. Tyshawn, are you where we at? So you came late.
No, I'm trying to get into it right now.
All right, so I'm just gonna give you the link and I want you to start it up. This is again inside your Bitmoji classroom if you guys want to check it out later. All right, so let's see here. Let's put this in the chat. All right, so that is a link. You can just click on that. And again, how does this system work? Why does it work? Right? Give it a shot. I'm gonna be asking someone. I'm gonna ask each of you, what do you think? All right, and this is for 25 points in class participation.
So all we're doing is trying to get the light to turn on.
Kyla, what you say?
I said, so all we're doing is trying to get the light to turn on.
Well, not only that, you got to tell me why it's on. Like I was talking to Jalen about what makes it turn on. And you're going to have to show on the screen exactly how that's working. So something in the air is happening to make that light bulb work. So it's one thing to turn it on. It's another thing to explain why. Tyshawn, are you on this screen?
Yeah.
So did you figure it out? Did everybody at least turn the bulb on? That should have been the easiest part, right? The next part is, what can you do to show why it's working? Why is the light bulb flashing on and off? Why isn't it just staying on? And Jalen kind of gave it away. He just doesn't know how to show it on his screen, right? So in a minute, we're going to share screens. Those of you that can, to get points. Or if you can't share your screen, you can tell me, and this is like maybe 2 shots. You give the class 2 shots at it. It's worth 25 points. But you got to each of you explain what you think is happening first before I tell you what's making it work. I'm just waiting for 30 seconds to run out. So I'm gonna have each of you explain to me what to do to make the bulb turn on. But the real question is, why is it on? What's making it turn on? There's no wires connected to it. Okay, there we go. Just come here, minimize, and all right, let's start with you, Tyshawn. Why does this work? He jumped on a different computer. Tyshawn, you there? You just jumped in. Okay. How do I make the light turn on?
You pull the thing in the loop area.
The thing in the what?
The loop area.
You talking about this?
Yeah. No, over there to the right.
To the right. Okay. But how do I make the light turn on?
The arrow thing.
The arrow thing? The compass?
No.
What?
I don't know what it is, but it's over there by the light bulb and stuff.
So you talking about this?
No.
Okay, I don't know what you want. Like, okay,
It's
so
in the pickup is in the pickup coil.
Pickup coil, okay.
But go down to where like the arrow stuff is at.
You talking about this?
No, go down a little bit more.
Here?
Yeah.
Okay, and do what?
Pull it to the side.
No, that's not enough. You're just making the coil bigger. Good try, though. All right, Jalen, what did you do? No, hold on. Michaela, you're there before Jalen speaks, because he's going to echo. Michaela, what do you think happened? Like, how do you turn this on at least?
I just turned that faucet right there. I just turned that up.
Faucet? Oh, okay. You just turned on the water. Right? But why is it flickering on and like the intensity of light is getting bigger and smaller, bigger and smaller? Why do you think that is? So you guys know what a compass is, right? This is a compass. So if you're traveling, say in the wilderness, you don't know where you're going. If you have a compass, it can tell you by the Earth's, I don't want to tell you what the answer is, but pull where you're going, whether it's North Pole, South Pole, East, right? So let's take a look at what's happening. All right, Jalen, did you figure out why this is working? Let me mute myself and see what he says. Waiting on you, Jalen.
All right. So, what I was saying was, so when you turn the faucet on, some type of magnetic energy going through the air that's making the faucet go on and off. Has something to do with the compass, something like that. That's it. I don't know what else.
Okay, I think that was close. I was looking for a way to show what's happening, right? So nobody noticed over here after you figure out how to turn it on, there's something called show field, right? That's a magnetic field meter. So it's measuring something, right? It's measuring the strength of the magnet in this area. All right, so click on that and you'll see how that works. Bx, By, and theta is the angle we talked about before. These are all values. And if we show the field, you'll see the diamonds change. So the magnetic field around is being altered by that magnet, and all you have to do is rotate the magnet. They put it on a wheel and spun it with the current, but that is all is needed because all you have to do is alternate the poles. All right, so that was a great activity. Everybody got points for participating. But now let's go back into Play-Doh real quick so I can make sure you know what you got to do and give you some time to work on it. So over here, let's review our objective. You should be working on Play-Doh. That was our in-class activity together. So let me bring this up. I think, let's see here. Tyshawn, you came a little late. Can you read the objective for us?
Students will be able to utilize Play-Doh Admentum online courseware kinetic and potential energy module to evaluate problems involving kinetic energy and potential energy. Classroom time of the day is gravity, word of the day, D-mean.
The mean. Yep. Okay, so let's take a look at this. You should be, again, logged into Play-Doh. You have the link information for Play-Doh in Edsby as well as in the chat. I'm putting in the chat again. And I'm going to remind you of what you're supposed to be working on specifically. So let me grab this Play-Doh link. And you should all know your password, right, and stuff. If you came to beginning class, you can see me type all that stuff in. And we're on, let's see here. We're on kinetic and potential energy in your physics class. So you're doing a mastery test. Let me just go through one question with you. Remember, you get credit for finishing the mastery with at least, I want to say, 100, or I'm sorry, not 100, 80%. So starting with this first question, right? Let's see here, Mikhaila.
Which one you say we on?
Kinetic and potential energy. So you got about 10 questions that can be randomized. It might be 5, it might be less. But you won't be able to answer them unless you go through and pay attention to the material in kinetic and potential energies tutorial. Okay, so I'm gonna give you a few minutes, but remember, your goal is to finish this mastery test.
Mr. Thomas.
Yes, ma'am.
Okay, so I clicked on my test. I didn't take it, but it locked me out.
All right, let me fix that for you. All right, did it unlock? Yeah, refresh.
Yeah.
Okay. Give it another shot. All right, so 10 minutes, everybody, and then we're going to share out. I'm going to look at the screen. I will know if you've been working on this or not. It's timestamped. So please do not use this 10 minutes to daydream, lollygag. Use this time to actually get most of this done. You don't want to be at the end of the quarter trying to do 10 sections, talking about how can I do the work you should have did in class. You don't have to worry about it, right? So knock it out now. You might want to go through the tutorials, and I showed you guys this yesterday. The easiest way, because students have used this over the years, is to, one, have open your tutorial, right? Tutorial was pretty much this one, and resize your screens. So if I do this, show you how to resize it. If I grab this over here, place that there, and spread that out. And again, it's playing with me. Mortal Kombat voice. Get over here. All right, we're gonna drag that. And that's tutorial running. And on one other screen, I'll have, you should have what? Your mastery test. I'm just showing you how other students have got out the class. If you do this, if you're on a computer, it's not hard because you can have a tutorial running. Now you can tab it too, some of y'all, but this is what I did when I was in college and in many institutions. So I have two screens running. One is my tutorial. So as I'm going through the tutorial, I'm looking for my question. This is an SAT tactic, all right, getting you ready for the real world. So as you go through, try to find the question you're trying to answer in the mastery test, and then also look at what you're doing in the tutorial. The tutorial will pretty much, if you listen through all the sections, give you the answers to your questions. If you get stuck or you locked yourself out or the test is locked out, just let me know and I'll reset it, okay? So 10 minutes. Don't forget about the objective, everybody, too. Not the objective, the exit slip at the very end. So let's do this. Okay, is that time to check in? We're going to review our objective. You should have at least started your Plato courseware and gotten at least through some of the tutorial and tried to answer some of the questions. Again, if you locked yourself out because it's 11:02, and I want to stay true to how I do things, we're going to let you go a little bit early so you can get ready for GGI Townhouse at 11:15 a.m. But let's do this. We're going to come to our objective. And this is what I want to remind you of, what's necessary for your exit slip. So I think, Michaela, you're up next. Tyshawn read. Can you read the screen here?
Students will be able to utilize Plato Elementum online course for kinetic and potential energy module to evaluate problems involving kinetic energy and potential energy. Lessons on today are gravity, vertically, and
Yes, ma'am. Thank you. All right. So with that said, and understand that you have two things you're turning in. Well, actually one. You're doing all of the mastery tests. You need 70%. If you take the test and they tell you got lower than that, just send me a message like Michaela did, and I'll reset it as soon as I can. All right. Some of you have a way to contact me via email. Worst case scenario is you can let one of the staff members know if I don't get around to it, but I can always reset it. You can retake it as many times as necessary to pass. So there's no reason to panic. Just try to get it out the way. So by tomorrow, we can move into the next section because you don't want to be falling behind. You got until 8 p.m. to turn in that exit slip. If I were you, I'd do it now before you forget about it because that's 30% of your grade. Plato is only 70%. So 30 plus 70 makes 100, your whole grade. All right, so let me come here. Remember, exit slip, full name, date, classroom name is Physics with Algebra. Tell me what to type in. You got to download this document first. I already gave you this information, and it's in ESB too. And what was the objective? That was what was just read by Michaela and several other people earlier. That is all accessible to by the Bitmoji classroom in case you need it. All right, so it's 11:04. Don't forget about Townhouse. Log in at that time. Get 5 to 10 points. The other big thing is the recording from yesterday is also there in case you want to go back and finish the exit slip because the exit slip information is in there. You start the YouTube video. I did put a YouTube link in there. It's the one with this thumbnail here, and you can watch it and find where the objective is and the word of the day and all that, and still do that exit slip. But don't forget about yesterday's Plato assignment, which was work, I think, right? Don't forget to get the 80% on that. All right, so that is it. Yeah, 11:05, I know. I'm right on cue. So that is it. I'll see you all at GGI. If not, I'll see you all tomorrow. Turn everything in by 8. All right, try to have 80% before 8 p.m., okay? That's all I got. You guys are free to go.